Okay guys, so welcome dito sa ating YouTube channel. Ito na yung lesson 28 sa ating Advanced Calculus 1. So this topic is all about Rolle's Theorem, pero may konti akong siningit pang theorem bago tayo mag Rolle's Theorem kasi kaya kailanganin din dito. Okay, so again, yung topic na to is magpo-focus lang sa Rolle's Theorem, tapos is I think one example para lang makita nyo ano yung application ng Rolle's Theorem na to. Okay, so let's have lemma number 6. So again, natapos yata tayo sa proposition number 5. So I guess that is the inverse theorem, or so I guess that is inverse theorem, no, naalala ko. So ngayon pumunta tayo ng left and right derivative, then saka tayo punta dito ulit sa Rolle's theorem. So ganun ulit, more improving ulit tayo. Okay, so let's have lemma number 6. So let D be a subset of real number, C element of D. So if f be a function mapping from D going to real number is differentiable at C, has local extremum at C, then f prime of C is equal to 0. So again, so kung meron kang daw function tapos differentiable siya sa C, tapos meron siyang local extremum at C, then f prime of C is equal to 0. So ano ba yung local extremum? Ito yung maximum and minimum point. So kung naalala niyo sa calculus, para siya na-discuss na yung pag kinuha ko yung first derivative, tapos kung for example, anong nangyari, yung kanyang local extremum, so yung local extremum niya is nasa gantong point, something gantong specific point, therefore siya ay yung f prime of c is equal to 0. So ito yung ibig sabihin ng lemma na to. So may re-recall lang tayo, ipapakita ko sa inyo before tayong mag-proceed sa proving nito, or before lating. So hindi to recall, so parang note na rin. Okay, so note that f has a local maximum so f has a local maximum at C. Okay, so C, if there exists C there exists delta greater than 0 such that such that f of x is less than or equal sa f of c. Okay, for all, this is for all c element, or x rather, so for all x element ng c minus delta, then c plus delta. Okay, so explain ko lang ulit. F has a local maximum at c. So again, magkakaroon siya ng local maximum, so parang local extremum din. Local maximum, iba siya ka extremum by the way. So f has a local maximum at C if there exists a delta greater than 0 such that f of x less than or equals f of c. So for all x element ng interval c minus delta, then c plus delta. So kung mapapansin mo, napakalit na interval na ito. Okay, tapos dapat na mangyari yung f of x less than f of c. So again, magiging local maximum siya doon. So meaning may local maximum ako at c kung ako ay mas malaki dun sa f of x. So for all value of x within dun sa interval lang. So again, hindi sa buong domain. So again hindi to yung buong domain. Okay, so in terms of drawing, paano ba magiging itsura niyan? I think mag-drawing na lang muna ako ng ganito para mas clear tignan. Para maintindihan nyo rin yung part na yan. Okay, so let's say ito yung function. So let's say ito siya. Okay, so let's say ito yung f. Okay, then gawa tayo dito ng kanyang mga c. So merong c dito. Tapos meron ding c dito somewhere. Sorry, not c. I guess parang dito yung c kasi ito yung maximum. Okay, so ngayon yung C na yan is napapalibutan nito. So si C na yan is nasa loob nitong interval to. So let's say siya, meron tayong dalawang ditong line. So si C na yan is somewhere nandito sa dalawang part na to. Okay, so sabi niya nasa loob siya ng interval na C minus delta tapos C plus delta. So obviously napakaliit talaga nung interval na yan. Okay, so parang naka-zoom lang talaga siya totally sa drawing na yan. So again, ito yung maximum. So hindi ko ma-consider na maximum to. Ito ay local maximum, to local minimum para sa function na yan. Okay, so alalahanin mo na lang din yung mga inflection point. Yun yung mga tinuro ko last time sa calculus 1 natin. Okay, so I guess we need to prove ito. So I think kailangan natin i-prove na yung f prime of c is equal to 0 kung siya ay differentiable sa local extrema. Okay, so paano ba natin ipoprove to? So ano ba yung mga way natin para mag-prove dito? Kung naalala nyo, meron tayong definition of derivative, meron tayong if equal si left and right derivative, then f prime exists, and yung Caratidore lemma. So kung naalala mo si Caratidore lemma, I guess pwede natin gamitin si idea ni Caratidore lemma para ma-prove ito. Okay, so check natin. Ito yung proof. Ipo-prove ko yung lemma number 6 ha. So ito yung proof of lemma number 6. Okay, so nakawala ng tinta yung aking block. So by Caratidore lemma, so same sabi niya, no, since f is differentiable at c. Okay, so lagay ka na lang, no, since f is differentiable at c, or ganyan na lang, f prime of c exists, then by Caratidore lemma, we have f of x minus f of c is equal to x minus c f sub 1 of x. Okay, so f sub 1 of x, where lagay ko na lang, no, where, so based sa definition ng Caratidore lemma, si f sub 1 is continuous at c. So don't forget na ilagay niyo yun pag gagamitin niyo yung ganitong klase ng proving. Okay, so again, since siya ay differentiable, kaya kong tawagin si Caratidore lemma na ito yung form niya. F of x minus f of c is equal to x minus c f sub 1 of x, where f sub 1 is continuous at c. Okay, ngayon, suppose, yun natin, dito kung tuloy ko na dito. So suppose f, okay, so suppose f has a local maximum, has a local max o local maximum at c. Okay, so kumbaga, what if, kung differentiable ako at c, so suppose na siya ay may local maximum at c. So again, iba siya kay local extremum. Okay, so kay local maximum, ito lang yung pwede mangyari. Okay, so since f has a local maximum at c, mangyayari to. Okay, then, this implies that f of x is less than f of c. Okay, so sabi nung ating note na nilagay ko dyan. Ngayon, since f of x is less than f of c, ano mangyayari dito? Ano mapapansin mo? So, mapapansin ko, sir, yung f of x daw less than c, therefore, ito ay lagging, dito ay lagging less than 0. Kung papansin mo, itong left side, itong right side is lagging less than 0. Bakit? Lagi kasi siyang negative. Okay? So, ano ibig sabihin nun kung lagi siyang less than 0? Okay ka na lang, ha? This implies that f of x minus f of c is less than or equal sa 0. Okay, so ngayon, ang kino-consider na lang natin, so aware tayo na yung x minus c tapos f sub 1 of x is greater than or equal sa 0 na. So okay, so ang kino-consider na lang talaga natin totally ay si x minus c times f sub 1 of x. Okay, so ayun na lang, kailangan natin makuha kasi yung ating f prime of c is equal to 0. Okay, so lagay ko lang, no, for all x element ng c minus delta tapos c plus delta kasi kasama sa definition. Okay, then ano ba susunod? May drawing ako dito, so I guess dito na lang sa kabilang part para lang medyo mas maintindihan niyo yung mangyayari. Ang gagawin ko, somewhere nandito si c. Okay, then somewhere nandito si c minus delta. Somewhere nandito si c plus delta. So, zinum ko siya na interval. Okay, so, assuming may function dito. Okay, let's say siya si f sub 1. Okay, so andyan sa f sub 1 natin. Yan, i-observe natin yung value ng x minus c. So again, saan galing yung x natin? So observe natin. So observe x minus c. Okay, ngayon, yung value daw ng x is galing sa interval na to. Okay, so if x is galing dito sa right side, pansinin mo, kung sa x is nasa right side, so meaning mas maliit siya kay c, so ano magiging value ng x minus c? So again, kung si x is nasa left side ng c, so meaning mas maliit siya kay c. Tama? So therefore, si x minus c is less than 0 or less than or equal sa 0. Okay? Now, kung si x minus c is less than 0, okay, then ang sabi niya, tingnan niya, kung sa x minus c is less than 0, so itong part na yun, kung ito ay less than 0, dapat ano to? Para maging greater than 0 siya. Okay, so ano dapat yung value ni f sub 1 of x para maging greater than 0 siya? Again ibig sabihin na x minus c less than 0, ibig sabihin negative to. Okay, so kung negative to, ano dapat yung value ng f sub 1 of x natin? Okay, so dapat ang value ng f sub 1 of x natin, this implies, lagay ko na lang, para maging greater than 0. Sir, bakit greater than 0? Kasi greater than 0 sila dito sa part na to. So dapat ang value ng f sub 1 of x natin, okay, f sub 1 of x natin is, I think this is also less than 0 kasi kung negative, positive siya. So greater than 0 tayo. So may possibility na mag 0 siya. So this is less than or equal sa 0. Okay? So again, ang ginawa ng sir, kung dito ako humugot ng value sa right side na to, yung value na x is mas maliit sa c. So meaning, x minus c is always less than 0. So observe na kung ito ay less than 0, greater than 0 sila as in. So dapat greater than 0. Yung product nila dapat is greater than 0. So ngayon, kung ito ay negative, dapat ano value nito? Negative din. Okay? So meaning, yung f sub 1 of x is less than 0. Ngayon, observe na kung dito natin kukunin sa kabilang part. Okay? So again, lagyan ko lang ng parang arrow. So ito ay para dito sa part na yan. Diyan tayo kumuha. Okay? Next is, what if kumuha naman tayo dito sa kabilang part? Okay? So observe ulit. And all or consequently, lagay ko na lang, so consequently, si x minus c sa kabilang side, kung mas malaki si x doon sa c, therefore x minus c is greater than or equal to 0. Okay, so meaning dito yan sa side na yan, sa left side kumuha. Okay, so kung dun siya mangyari, ano dapat yung value ng f sub 1 of x? So this implies na si f sub 1 of x is greater than 0. So ano nangyari? May dalawang value tayo ni f sub 1 of x. Ang value ng f sub 1 of x natin is less than or equal to 0 and greater than or equal to 0. Ngayon, kailan mangyayari yun? Mangyayari lang yun. So this implies, so again mangyayari lang tong dalawang to if f sub 1 of x is equal to 0. Okay, now, since si f sub 1 is continuous at c, therefore, this implies that f sub 1 of c is equal to 0. Then by definition of Caratidori lemma, this implies that f prime of c is equal to 0. And that is done. Okay? So, ganun yung ginawa kong atake para ma-prove yan si lemma number 6. So, kung napansin mo, ginamit ko si Caratidori lemma tapos based sa observation dito. So, minsan ganito talaga mag-prove sa calculus. So, check mo saan manggagaling yung value ng x. Then, ganyan. Okay, now, let us proceed dun sa ating topic talaga. Actually, topic din talaga natin yan kasi related naman talaga si totally dito. So, this is proposition number 7. So, this is the Rolle's theorem. Okay, so, if f is a function mapping from a closed interval AB going to real number is continuous on AB, so sa closed interval AB, or differentiable siya on AB. So, dalawa ibig sabihin na, kung ako ay continuous sa closed interval AB, or differentiable ako sa open interval AB, and f of A is equal to f of B. So, dalawa, ganta. Nyari, continuous ako sa closed interval, tapos equal tong dalawa. Or, differentiable ako sa open interval, tapos equal tong dalawa. Then, there exists C, element ng AB, such that f prime of C is equal to 0. So, kung napansin mo, sir, parang pinaghugutan niya siya dito. Yes, parang pinaghugutan. Pero, ano pinagkaiba ni Rolle's theorem dito? Dito kasi is specific domain. So, meaning, nakatingin ako sa isang point. Okay, so sa point na yon, kung siya ay local extremum, automatic yung f prime of c ko is equal to 0. Dito naman, kung ako ay differentiable sa AB, and or continuous dun sa closed interval AB, tapos yung f of A is equal to f of B ko, so meaning yung dalawang dulo ko, yung dulo-dulo, f of A is equal to f of B, so meaning yung f prime of c ko is equal to 0. So I guess para mas maintindihan mo, I think kailangan ko siya ng konting illustration para makita nyo rin or maintindihan yung in-explain ni Sir dyan. So for example, ito yung drawing. So ito rin yung medyo na-ready ko dito. So for example, ito yung A. Tapos ito yung B. So gusto ko may represent yan eh. Sabi na yung f of A is equal to f of B. So gagawa ko ng function na kung saan equal sa f of A saka sa f of B. Kung ikaw ang tatanungin ko, equal ba sa f of A saka sa f of B dyan? Yes sir. Bakit? F of A is that point, f of B is that point. Okay, so meaning sa f of A is 0, sa f of B is 0. So nagkataon na tinapat ko mismo sa x-axis. Okay, then next is ngayon magkakaroon siya at some point na C. So for example, may local extrema dito. So for example, ang gagawin ko somewhere na mag-x dito yung local extrema. Okay, then somewhere dito. So let's say dito isang C. Okay, then meron pa dito isang C ulit. Okay, tapos may isa pa tayong C dito, mas mababa. Okay, so gumawa lang ako ng parang mga local extrema niya. So kumbaga, pag dinifferentiate ko, ito yung local extrema niya doon, o yung local maximum niya, local minimum, tapos local maximum extrema, tapos local minimum niya. Sa part na yun. Okay, so ginawa ko lang siya, kumbaga function pa lang siya nung dinifferentiate ko sa ito na itsura. Kumbaga bumaba, kumbaga it's either bumaba dito sa part na to or lumangat doon. So parang nire-represent lang niya nung nag-undergo ng differentiation, nagkaroon ng mga nahanap natin yung mga local extrema, local maximum, local minimum. Okay, so yun yung mga in-explain lang dyan. Okay, so now ang goal natin is we need to show na dapat ganun yung mangyayari. So again ha, intindihin mo mabuti. Dapat continuous dun sa closed interval. Pangalawa is differentiable dun sa open interval. And dapat yung f of A is equal to f of B. So it is not necessary na dapat laging f of A is equal to f of B na 0 sila parehas. Pwede rin nandito sa taas ganda. Okay, kung ba inangat or nasa baba, something. Okay, so yan yung mga dapat natin i-consider. Another thing na dapat ma-consider mo, yung dulo-dulo. Yung dulo-dulo yung chinecheck dito. Yung dulo-dulo ng interval, yung chinecheck natin dito. Okay, so I think we need to prove this. Gamit na ako ng ganito. Mas nasanay na kasi ako dito sa sign pen. So I guess sa mga next video na gagawin ko sign pen na gagamitin ko. Medyo maganda tignan. Tsaka mas thin. So napansin ko mas zoom kasi yung cellphone. So kaya pala talaga. So next time siguro baka G-Tech na gamitin ko kulay blue or something na mga ganun. Para mas malinaw siya. Okay, saka para mas napansin nyo, mas maganda yung sulat ko tignan. Mas naiintindihan. Okay, ngayon since F is continuous. Okay, so ito alam ko no, since F is continuous on closed and bounded interval AB. Okay, so aware tayo dyan. Lagyan na, since F is continuous on closed and bounded interval AB, so sabi nung ating definition dati ng maximum and minimum ng function, so kung naalala mo yung ang tawag dito, EBT, extreme value theorem. Okay, so there exists C sub 1, C sub 2 element ng closed interval AB. Okay, such that by EBT yung F of C1, for example, sinagad ko sa F of C1, yari ito yung C1 na yun, kinuha ko. So for example, ito yung C1 and yung maximum na yan. So F of C1 is the maximum of F of X. Okay, such that X is an element ng interval AB. Okay, so let's say na sa F of C1, F of C2 rather, this is the minimum ng F of X such that X is an element of closed interval AB. Okay, so sinet ko. So ito ay by EBT. Okay, so may nag-exist na minimum saka maximum dun sa loob ng function. So let's say ito yung C1, ito yung C2. Okay, so yan yung mga kinukuha ko. So sorry, F of C1, F of C2. Okay, now, ang gusto natin patunayan is dapat yung f prime of c is equal to 0. Okay, so napakadali lang nung proving nito. Ito yung mga possible na mangyayari. Una, if C1 or C2 is an interior point, so ano ibig sabihin ng interior point? Kung si C1 and C2 is interior point, meaning nasa loob ng domain. Okay, so ano ba definition sa derivative? Sa derivative, si C is interior if siya ay napapalibutan ng isang maliit na interval, kung may mag-exist na delta. Okay, kung si C1 and C2 is interior, meaning nasa loob talaga sa totally nun, okay, then we are done. Okay, then we are done. Kasi ano ibig sabihin? Nasa loob lang siya. Kumbaga, kumbaga nangyari is parang trivial na lang. Kumbaga, kung kaming dalawa is interior, so therefore automatic kung kami dalawa ay interior, so therefore nasa loob kami ng function. So therefore yung f prime, so kumbaga trivial siya, therefore yung f prime of c ko is equal to 0. As another thing na pwede kong sabihin is, sir, what if, ano ba yung ibig sabihin mo na sila, kumbaga interior point? Kasi ganito, for example, si C1 ko, si A pala. Si A, hindi ko pwede sabihin interior point. Bakit? Hindi ko siya, kasi siya yung dulo, yung interval. Kumbaga, meron ditong parang mapuform. So, makaka-form ako ng open interval, pero wala sa loob ng domain. Okay, so kung si C1 nasa loob, si C2 nasa loob, therefore automatic kung interior point sila. Tapos na tayo. Okay, no need na. Bakit, sir? Kasi proceed na. By lemma number 6, f prime of c is equal to 0. By lemma number 6, si f of c1 is local maximum. So, si c1 is maximum natin. So, therefore, by lemma number 6, tapos na tayo. Okay, yun yung ibig sabihin yan. Kaya sabi ko, tapos na tayo dyan. Okay, next is, yung pangalawa, if both, so again, or yan ha. So, meaning ng or is, either sa dalawa lang yan. Okay, kasi isa lang naman kailangan eh. So, it's either f of c1. So, f prime of c1 is 0, and f prime of c2 is 0. So, kaya or. So, what if both c1 and c2 and c2 are endpoints? Okay, so ngayon, what if both C1 and C2 are endpoints? So meaning, sila yung A, sila yung B. Okay, ito si C1, ito si C2. Ano napapansin nyo? Ang ibig sabihin, kung siya ay merong, kung silang dalawa ay endpoints, based sa drawing ni sir, ano masabi nyo? Based sa drawing ni sir, then, f of C1 is equal to f of C2. Okay, since f of A is equal to f of B. So, sir, bakit, sir? So, si A is equal kay C1. So, meaning si f of A is equal to f of C1. Then, si f of B is equal kay f of C2. Therefore, f of C1 is equal to f of C2 or sub 2. Then, since f of A is equal to f of B. Okay, so, ibig sabihin, ano ibig sabihin yan? Kung ganyan nangyari, equal siya. So, ibig sabihin, siya ay constant function. Yun is assure. So, another thing hindi ako dito nakasure Kung nangyari, f of C1 is equal to f of C2, ibig sabihin, yung magiging drawing ng function natin is something ganito. Horizontal line. Okay, ganyan yung mga nangyari dyan. So, kung ganyan yung nangyari, then, f is a constant function. So, then f of C1 is equal to, so, lagay ko na lang, f is a constant function. Okay, now, this implies, ngayon, ano ibig sabihin? Kung si f is a constant function, this implies that f prime of c is equal to 0. And we are done. So, this is for all c element of a, b. Sobrang ko yan. Sir, bakit gano'n nangyari? Ganito kasi yan. Kunyari yung constant function, dinifferentiate ko, evaluated ko at c. Ano yung derivative nun? 0 pa rin. So, for example, f of x ko is equal to 3. Ano yung f prime of x nyan? F prime of x is 0. Ano yung f prime of 3? F prime of 3 is 0. So, kahit ano ipalit kong value sa f prime of x, 0 ang sagot. So, meaning f prime of c is equal to 0. So, ayun lang yung nangyari. So therefore, Rolle's theorem is proved. By the way, this is just only the existence. So wala pa dito yung uniqueness niya or something. I don't know kung uniqueness, kung meron siya uniqueness. Pero yung Rolle's theorem na to, yung sinasabi ng Rolle's theorem dito is yung yung existence niya. Kumbaga yung may nag-exist na C such that yung f prime of C is equal to 0. So ito yung ibig sabihin ni Rolle's theorem. So provided na dapat interval yung domain. Okay, so again gumagana si Rolle's theorem pag closed and bounded interval yung domain natin. So ito yung mga isa sa mga restriction ni Rolle's theorem before mong gamitin. Okay, now show that f of x is equal to x cubed plus 3x minus 10 has a unique real root. So paano natin masasabi na may unique real root siya? Masasabi natin may unique real root siya kung yung f prime of c, kung yung f prime of x natin is not equal to 0. Again, masasabi mong unique siya. This is unique. Unique yung isang function kung yung f prime of x is not equal to 0. Okay, so ngayon I think pakita natin siya na hindi ko naman hindi to proving, nagkamali lang ako ng dapat determine if f of x is equal to x cubed plus 3x minus 10 has a unique real root. So hindi siya talaga proving totally. Okay, so ano ba yung mga dapat nating i-observe dito? So para makita nyo yung mga application ng mga pinagagawa natin last time. Okay, so observe natin. So observe. Okay, so observe that yung limit as x approaches positive infinity ng f of x. Okay, so pansinin nyo, yung limit as x approaches positive infinity, that is also positive infinity. Okay, and yung limit as x approaches negative infinity ng f of x is negative infinity naman. Okay, so based sa mga observation, ganyan siya. So, kinuha ko yung limit ng function as x approaches infinity. So, kumbaga, wala kasing fixed value eh. Okay, so kaya in-approach ko sa infinity sa negative infinity. Kumbaga, kinuha ko na yung dulo-dulo sa buong real number. So, kung papansin mo, yung function natin is still continuous sa buong real number. Kumbaga, gagalaw lang ako. Okay, so, hindi sa eksakto yung limit niya pagdating sa mga ganyan. Okay, so, ibig sabihin, by IBT, so pwedeng gumana si IBT. Bakit? Kasi continuous siya sa buong domain. Okay, so by IBT, so tawagin ko na lang si IBT. So by IBT, or by the intermediate value theorem, okay, so there exists at least, okay, there exists at least one C element ng real number, okay, such that si f of C is equal to 0. Again, so by IBT, so again, ganito. Pag yung function, kinuha ko yung limit niya going to approach, going to positive infinity, tapos limit niya going to negative infinity, tapos magkaiba, kumbaga tuloy-tuloy lang, positive infinity, tapos negative infinity. So, ibig sabihin yung function is stretch out lang, kumbaga malaki lang siya, kumbaga walang dulo, gano'n ibig sabihin. So, sure ako, by IBT, may at least isang C dyan, element ng real number, kasi domain natin is a real number, such that yung f of C is equal to 0. So, somewhere daw, i-cross niya yung x-axis. So, yun isa sa ibig sabihin niya. Okay? So, yan isa sure ko. Okay, ngayon, suppose, yung f natin may real root. Okay? So, what if, suppose f has another real root. Okay? So, for example, bukod kay C, may isa pa siyang real root. So, kasi expected ko, tatlo yan eh. Okay? So, suppose, bukod kay C, meron pa siya isang real root. So, that is, okay, so that is, there exists D, element ng real number, okay, such that, si f of D is equal to 0. So, again, by IBT again, sure ako meron D, such an element ng real number, such that yung f of D is equal to 0. Okay, so kunyari may exist na ganyan. Okay, so since may nag-apply ako, since meron nag-exist na ganyan, hindi ko alam somewhere o somewhat nasaan siya sa function natin. Okay, so hindi ko alam ano yung itsura ng function natin. Okay, so although alam ko yung itsura ng function, sorry. So for example, ito yung itsura ng cube kasi siya. So hindi ito yung eksaktong graph niya ha. So, ang gagawin ko lang is konting representation ng parang magiging graph. Okay, so kumbaga tuloy-tuloy siya doon. Okay, so sabi niya meron daw C somewhere dyan. So, parang ang contradiction na ginawa niya is meron daw C. Okay, may C na kung saan yung f of C, yung f of C is equal to 0. Tapos meron D na yung f of D is equal to 0. Okay, so parang tingnan mo, contradiction nangyari. Kumbaga meron akong C. So sure ako meron isa doon eh. So kung i-graph mo kasi yung isang cubic function, isang beses lang siya mag-cross sa x-axis. Pero yung ina-assume ko is dalawa nangyari. By IBT, nakuha ko na isa. Then another thing, sabi ko suppose meron ganyan, kumbaga ito yung parang contradiction part. Kumbaga okay, gawa tayo for example ng ganito. Okay, so ano purpose, bakit ginawa ni sir yan? So meron tayong C and D. So let's say nandito somewhere yan dito. So parang for example is somewhere nag-cross out siya dyan. So we can use, we apply Rolle's theorem. Okay, so we apply Rolle's theorem to F on interval CD or DC. So sir, wala naman po ako nakikitang interval dyan. Yes, wala nga, pero nga assumption lang. So yes, para napindot. Okay, so tuloy again ha. We apply Rolle's theorem to F on CD or DC. Okay, so again ha, ito yung maring mag-ano sa'yo. Sir, bakit? Again, sabi ko nga, merong C, somewhere doon. Tapos meron pa isang D. Kumbaga, may somewhere pagdating dito sa point na may interval. Kumbaga, parang nangyari ng graph, naging drawing ng graph is somewhere. Pagdating dito, gumanon, tapos gumanon. So, somewhere, andito si C, andito si T. May gumuhang interval. Pero, imposible yan ha. Kumbaga, parang ito ay way ko lang para ma-prove natin siya ng maayos. Okay, so we can apply Rolle's theorem so CD and DC. Then, there exists E. Okay, since meron tayong interval, so meron tayong interval na close and bounded interval. So f is continuous doon, sure tayo kasi function is continuous diyan. Okay, so by Rolle's theorem, there exists C or there exists E. Okay, element or between, there exists E, so ika lang E, between C and D. Okay, such that f prime of E is equal to 0. So, ayun yung sinabi nun. So, for example lang, may nag-exist na D, somewhere ganun nag-iitsura niya. Okay, pero, lagay ko lang, ano ba derivative ng function natin? But the derivative of f prime of x is equal to 3x squared plus 3. Okay, which is not equal to 0. Which is can never be equal to 0. Okay, on real number. So, kahit anong value ng real number, hindi natin magiging 0 yan. Kasi, ang pinaka sure time value, kunwari x is equal to 0, this is 3. Okay, so f prime of 0 natin is 3. So, lagi siyang may value, which is this is a contradiction. Okay, so sir, bakit? Yung f prime of e daw is equal to 0. Ayun sabi niya, yung f prime of x, 3x squared plus 3 can never be 0. So, meaning, meron siyang real root. So, meaning, yung f prime of x ko is not equal to 0. Therefore, siya ay may unique real root. Yun lang yung kanyang ibig sabihin. So, again, ganito mo siya isa-show. So, kumuha ka ng konti dalawang interval, apply mo si Rolle's theorem, tapos kunin mo yung derivative. So, sir, pwede ba ganito na lang? Kunin ko yung derivative, tapos ganito. Hindi pwede. Bakit? Kailangan ipakita mo pa rin na merong interval. Kailangan pakita mo na nag-a-apply si Rolle's theorem natin. Okay, so that's all and thank you for watching. Hoping na panoorin mo yung next video natin and that is all about mean value theorem.